But we're here to talk about one of our favorite things. That's cold data.
I'm sensing people have some cold data in the room.
Ooh.
Good news.
Good news.
That's what we're going to talk about tonight.
Well, good evening. My name is Gayla Beasley. I'm a Senior Technical Program Manager with Amazon S3 Glacier.
My name's Andrew Pohl. I'm a Principal Product Manager with S3.
We're here to talk about what's cold data, Andrew.
Cold data. I'm glad you asked, Gayla.
Thank you.
We think of cold data as data that you're not accessing more than about once per quarter. And it's data that typically, after a certain period of time, is accessed less and less, but you want to hold on to it for a particular reason, and, well, we're going to go into that.
All right, let's get started.
Now, time to take off the jacket. Get serious. First of all, thank you so much for coming. I know 5:30, challenging time, but we're really excited to talk about this with you. Now, I think I should have a clicker. Here we go. So what are we going to talk about today? Let's see. Oh, I'm pressing the wrong button, that's why. My bad. We're going to talk about why cold data is important. And then we'll talk about storing that data in S3. And specifically, we'll talk about best practices of how you can reduce your costs of your data over time as you're accessing it less. And then in the second section, Gayla is going to come back on stage and walk you through restoring that data and what to think about performance-wise, best practices for how to get your data back out of S3 when you want to utilize it. So first, cold data is really hard to ignore because as your business is growing, you're probably putting more and more data. And as that data ages, it's typically accessed less. In fact, IDC estimates that anywhere from 70 to 80% of the world's data is cold, or in other words, it's not being accessed. The one thing that we see is kind of a trend across customers is that they're keeping that data for some type of future use. And there's a major trend right now, too, with AI/ML, where that data is actually increasing in value over time because customers are finding new ways to use it with new applications. And so it's a very exciting time to be working on cold data. Now, while customers store data for lots of reasons, we really see these fall into three major kind of macro use cases. The first is preservation, where you might be storing media files, say it's video or images. Could even be historical data in a data lake, where you know it has value to use in the future. You want to be able to access it, but you also need to make sure you can reduce the costs on that data so that as you're storing more and more of it, you're not exponentially growing your costs as well. Now, we also see a lot of customers with backup use cases. And backup, oftentimes, you're hoping that you won't actually have to restore that data. However, when you do need to restore it, it's absolutely critical that you can get it back within your recovery time objective and kind of make sure that all of that is working when you do retrieve it. And then finally, customers store cold data for compliance. Now, customers often have retention requirements, could be government or even self-imposed because they want to retain data. And those could be anywhere from 5 to 10 plus years, maybe even forever. And if you're storing data that long, you've got to make sure that your costs are low enough so that you can do that successfully without ballooning your cost. So one thing that I heard from a customer, I think it was about 6 months ago, was they told me that during the pandemic, they were looking through their data for things to delete. They were shortening retention windows, and granted, it was very uncertain economic times, and they needed to reduce their costs. However, somebody raised their hand as they were deleting data and mentioned, with all of the new AI ML capabilities and other things that we could potentially do with this data, are we too quickly deleting it and not thinking enough about what we might do with it in the future? And so they looked back and they decided to actually focus more on trying to reduce their costs as opposed to deleting as much data, because they knew that that data had future value. They just weren't exactly sure how they were going to use it. And for any of you who went through the pandemic or recent economic uncertainty, that might resonate with you as well as you're looking to try to reduce your costs. And of course, deleting data is one of the ways you can do that. But the good news is with Amazon S3, we've got storage class options that are regional. These are all of our regional storage classes, which mean data stored across a minimum of 3 availability zones. And from left to right, on the left, for data that you're accessing more frequently, you can pay less for access, but pay more for your storage. And then as you move right, you can actually reduce your cost of storage as you're accessing data less. And so with S3, when you're holding on to data for longer periods of time, as long as you're moving your data to these colder storage classes, and I've highlighted Glacier here on the far left, which we're going to go into more detail, if you're moving your data into these storage classes as your data is accessed less, the trade-off is your access costs increase, but your cost of storing the data decreases. And then if you move on to Glacier Flexible Retrieval and Glacier Deep Archive, and you're willing to trade off accessing data in milliseconds for hours or maybe even days, you can actually then even save on your access costs too. So you can actually get the best of both worlds where your access costs aren't quite as high and your storage costs are lower if you're willing to trade off the time that it will take to access that data. So now let's go into the Glacier storage classes. I'm going to go from left to right and just talk about a couple of use cases that are great fits for these storage classes. So on the left, we've got Glacier Instant Retrieval. Now, the key thing to remember with instant retrieval is that it's got instant access, which means that your application can use the same GET API call to access your data. Or in other words, if you move data into instant retrieval, you don't have to change anything about your application. So what use cases work really well with this? Think things like medical images or user-generated content. For example, if I go to the doctor's office and they need to pull an X-ray from 3 years ago, ideally they would do that right then. They don't want to wait for hours. Speed is of the essence, and so within milliseconds, I can pull that X-ray image and review it, and chances are that images that are that old are not being accessed very often. And so I can keep my costs down because my access is low, but by storing it in Glacier Instant Retrieval, I also reduce my storage cost. Now, Glacier Flexible Retrieval has a lower cost of storage. However, you have to wait for minutes to hours to retrieve your data. And I'll just point out here, this can be really great for use cases where you may actually need to retrieve large amounts of data. And the reason that is because you can retrieve with the bulk option, which is takes 5 to 12 hours. You can do that for free. And so what customers do is if they have potentially large pieces of their data that they want to restore for, say, an AI ML application, they can do that, and it doesn't have to increase their costs to restore that data. And then finally, with Glacier Deep Archive, it's got the lowest cost of storage at about $1 per terabyte. And this works really, really well for long-term retention use cases like compliance, where you know you're not going to access a lot of your data, and also you're really looking for the lowest cost of storage in order to keep your costs down. But now it kind of leads to the question, how do you get your data into these storage classes? And that's where S3 Lifecycle comes in. Now, some data, for example, backup data, you already know that it's cold. If you're archiving data, there's really no need to use Lifecycle. You can put it directly to the storage class that makes the most sense. But for a lot of data, it gets cold over time. So it's used frequently within the first 30 to 90 days, and then after that, the access drops. And so for that, we have S3 Lifecycle transitions. So I'll just go over a quick example. Let's say you create an object on day 0, but after 90 days, you observe that the access pattern has gone down to less than 5% per month. You can use something like storage class analysis to view that, or S3 storage lens to look at your access patterns. And if that's the case, you can set a lifecycle transition policy to move the data, in this case to Glacier instant retrieval, after 90 days, and that's if you still need millisecond access with gets. Now let's say after another 90 days, or a full 180 days after I've created the object, I no longer actually need that millisecond access. I can create another lifecycle transition rule underneath my policy to move that data after 180 days to Glacier Deep Archive and save even more on my storage. And then finally, if after 7 years I no longer need the data, I can delete it. I can use lifecycle expirations, set another rule under my policy to delete the data after 7 years. Now, lifecycle has multiple different filters that can help you select which storage you're actually going to transition or expire. The key ones are bucket, prefix, and object tag. Now, if you think ahead about how to organize your data, you can actually put data into a prefix or bucket that is accessed or kind of has similar access patterns, and that'll make it much easier down the road to set up these policies. And now let's say, maybe you didn't do that and you have different customers kind of within, or you're managing your own customers, maybe they're internal, under one prefix or bucket. You can still use object tags to tag your data and then move the data based on the tags. Now there's a couple more filters mentioned here. There's object size, which I'm going to go into in depth here in a second. And there's also number of versions. Now, the reason I just want to mention number of versions really quickly is if you do turn versioning on, which is important to make sure that you're seeing the multiple versions that you've created, you don't want to necessarily hold on to all of those versions forever. That can really increase your costs. So for example, if I'm creating version after version and suddenly I have 20 versions, my storage cost is 20 times. With this filter, I can select how many versions I want to maintain while expiring versions after a certain amount, and I can also set that by time. So let's say after 30 days, I don't want to have so many versions. I can use that filter to control how many I'm storing. Now let's talk about object size and why that's so important. So up here on the screen, I've got a little analysis for you. On this chart, on the x-axis, we're showing object size. And on the y-axis, we're showing months to break even. And I think the best way to explain this is to just give an example. The way we think about break even is how long does it take me to save money? So in a very simple example, let's say I'm moving data from S3 Standard to S3 Glacier Deep Archive. I'm paying $23 a month in S3 Standard. And in Glacier Deep Archive, I can pay $1 a month. And okay, that's a $22 a month savings. So that looks good on the face of it. But if it costs me $22 to transition the data into Glacier, it's actually going to take me 1 month to save money. So if you're transitioning objects that are 128 kilobytes in size, that same transition would take 20 months to save money. And for a lot of customers, 20 months is too long. I don't actually want to pay necessarily upfront to move my data to Glacier Deep Archive and then wait those 20 months. And so what a lot of customers do is they focus on larger objects, which break even much sooner. So for example, if I move objects that are 2 megabytes, now I save money in 1.5 months. And that looks much better. Now finally, one last thing I want to mention on this topic is we actually recently changed a default where now all objects under 128 kilobytes do not transition to any storage class. And it's primarily because we heard from customers that they really wanted to break even faster than 20 months. And sometimes they were surprised when it took longer. And with that new default, now 20 months is kind of that baseline. Now we take changing defaults very, very seriously. And the reason is we don't want to introduce any sort of breaking change. And so in this case, what we coupled this with was also the ability to move objects under 128 kilobytes if you use the object size filter to set a minimum object size below 128 kilobytes. So for some customers, they understand the break-evens and they're going to store data for 7+ years. And they've already done the calculation and they want to move, say, 64 kilobyte objects and above. They can still do that with the object size filter. But for those customers who just want to rely on the defaults, now it's significantly easier to do that. So now that I've talked about object size, I want to take you through an example of how an actual customer looked at this, and that customer is Canva. Now Canva is a digital design platform that allows their users to create and publish just about anything. And they launched in 2013 and grew to over 100 million active users. So you can imagine their data footprint has also been growing. Now, they looked at their data, and they were already partially optimized. They were using standard infrequent access for a large chunk of their data, but they thought they could save even more with Glacier Instant Retrieval. So they looked at their access patterns and sure enough found that they could save more with Glacier Instant Retrieval. However, they also looked at their object sizes and realized that they needed to transition data that was 400 kilobytes or larger in object size so they could break even within 6 months. So they took stock of what they had. They had a lot of data that they couldn't move, frequently accessed things like stock images and designs that they were publishing. However, the user uploaded images, those were getting cold much faster. And so they were able to move a large chunk of that data to Glacier Instant Retrieval and save money. And then finally, they also looked at their logs and backups and found like they didn't really need instant access. And so they moved that data to Glacier Flexible Retrieval to save even more. And at the end of the day, they were able to save $3 million a month by making those transitions. And they still were able to break even within that 6-month period. Now, just like Canva, a lot of customers think of their S3 footprint as a continuum where at the beginning of the data's life, it starts in S3 standard as their customers are accessing it, and then over time, they can lifecycle it to other storage classes. Now I'm gonna bring this back from the 2022 archives because it's such a great example. NASCAR is a stock car auto racing company. And on race day, they're getting a lot of raw footage. They're processing that footage, they're creating proxies, or doing a bunch of things with it, but then on the second day, they're basically done with most of the footage, and they actually found that they could move that data directly to Glacier Instant Retrieval on day 2. And so you can imagine they saved quite a bit of money by doing that. Now, not every customer is like NASCAR. You might have a use case where you don't know what your access pattern is. And the good news is there's ways to save money there too. In fact, we're hearing from more and more customers that they really want that easy button to save money on their storage, and that's where intelligent tiering comes in. This is the storage class to use if you don't know what your access pattern is, or maybe even you want to learn about your access patterns, because this can help you do that while saving you money automatically. as you don't access your data, it transitions down to the lower tiers, which are lower cost. So for example, after 90 days that you don't access an object, it moves down to the archive instant access tier, and that's the equivalent price of Glacier instant retrieval. The other great thing about this is that you can still use the same GET API to access your data. So nothing changes there. Your application can consume this data, and you don't have to make any changes to it. Now, just really quick, when might you not want to use intelligent tiering? I want to touch on a couple of those as well. The first case is if you're like NASCAR, where you know you're not going to access your data very much after the first day. And if that's the case, using Lifecycle, you can transition your data much more quickly, right? Day 2 versus day 90, and save quite a bit more. The second reason that you might choose S3 standard versus intelligent tiering is it does have a lower availability design. It's 99.9% versus 99.99% for standard. And the way I like to think about it is that means that 1 in 1,000 requests is going to fail and need to be retried versus 1 in 10,000. So for very performance-sensitive applications, that's a trade-off that you can make. And a lot of our data lake customers have chosen intelligent tiering, despite that difference, because the cost savings is worth that much to them, as opposed to the trade-off in performance is fairly small. Now, there's one more aspect I want to talk about with intelligent tiering, and that is the ability to opt in to archive access and deep archive access tiers. So, of course, I'm really excited about this because I like archival data. But with intelligent tiering, you can basically save money just like moving data to Glacier Deep Archive, but you don't pay for the transition costs to move it in. This is a setting that you can apply instead on your bucket. The key thing to remember here is that data that does get transitioned will have to be accessed with a retrieval API request, which Gayla is going to go into. So let me just walk you through really quick how to turn it on. You'll go into your bucket properties in the S3 console, and you select properties underneath your bucket. Then you can scroll down, you'll find this intelligent tiering archive configuration. Click on Create Configuration. Now you can actually filter this by prefix or tag, just like a lifecycle rule. And remember too, this is a bucket policy, so it's already filtered to your bucket. And then the final thing I'll mention, which is important to a lot of customers, is you can select how many days after an object isn't accessed that it will move. So for many customers, the defaults of 90 and 180 days for archive and deep archive access, that's just too short. They can't have their application failing after just 180 days after an object was created. However, if you wait a little bit longer, like in this example, I picked the maximum, about 2 years, 730 days, oftentimes it's okay if that data isn't immediately accessible with the GET API. In fact, a lot of customers prefer it. For example, if I'm storing a data lake and my data hasn't been accessed in 2 years, I don't necessarily want my intern to go and do select star on my table and pull data from 2010 to 2015. If I have this turned on, if that data hasn't been accessed, it will have already been tiered down, and then I can make a business decision about whether I want to restore it and move all that data back to the frequent access tier, or maybe I don't, because that will carry a cost. So that brings me to the end of the storage section of this, and I just want to review really quick some of the main things we talked about. The first is make sure to reduce your storage costs by using Lifecycle or intelligent tiering. The second is choose Glacier storage classes based on your retrieval needs. If you need things in milliseconds, Glacier instant retrieval. Otherwise, you can save more money with flexible retrieval or deep archive. And then finally, moving objects that are larger will help you save money much more quickly by breaking even faster because the costs of moving that data are less. So now I'd like to call Gayla up to the stage to do the
talk to you guys about how to get your data into Glacier, and I'm here to help you get your data out of Glacier because you will occasionally need to access that cold data. So we've observed a few common themes with our customers when we ask them why they choose to restore. You could be a media company who wants to access some archival content or footage to generate new content for your customer. Or maybe you're restoring a backup, which you need to fulfill some type of new compliance requirement. And as Andrew mentioned, we're also seeing a lot of our customers restore their cold data, their archive data, to build machine learning platforms or do analysis on their, on their archive data. So there's a bunch of different reasons why you might need to restore, and we're going to talk to you now about how to do that. So first, if your data is in Glacier Instant Retrieval, it's pretty simple. It's the same GET call that you would use for the S3 synchronous tiers. It's the same as that you use for standard, intelligent tiering, or SIA. And if your data is in Glacier Flexible Retrieval and Deep Archive, you're actually going to have to submit a restore request. And this is typically best for those customers that can withstand a longer retrieval time of hours to days, whereas Glacier Instant Retrieval, as Andrew pointed out a few times, is intended for that instant access. So just to give you an example for instant retrieval, let's say that you are running an application that has user-generated content. And maybe your customers are like me and they love their dogs and they're uploading all types of pictures of their dogs, right? You may want to retain those images or videos forever, or at least for as long as your customers have accounts with you. And your customers are going to expect to be able to access that data periodically. And that's where instant retrieval is the best use case for this type of content because you get that millisecond access. It's ideal because you can lower your TCO for your storage and fulfill your customers' needs for getting that instant access. But if your data is in Glacier Flexible Retrieval or Glacier Deep Archive, again, you're going to have to do a restore request. So let's talk about how that works. There's 3 steps. First, you're going to have to initiate your restores. Then you're going to have to check for completion. And then you're going to access that restored data. And I'm going to take you into each step. So for initiating restores from Amazon S3 Glacier Flexible Retrieval, you're going to have to determine what is the best restore type for you. And you're going to weigh that against time versus cost. So how long you want to wait for the data versus how much you want to pay for the restore. Next, you're going to determine how much time it's going to take to initiate all of your requests. And then finally, you're going to have to determine the number of days that you want your temporary copy to remain in S3 standard. And we'll go into each of those as well. So choosing your restore type. Andrew already talked to you about bulk retrieval, but I want to call it out again here because it's one of the one of the best cost-saving features we have because it's free. So if you have to restore a large amount of data from Glacier Flexible Retrieval, and you have the time to wait between 5 to 12 hours, bulk restore is your best option. And you should really consider making it your default option because it's the best cost savings there. But let's say you need your data back a little quicker, and you're going to use a standard restore. Normal standard restores, you can see anywhere between minutes to 5 hours. You can see those data back in minutes when you use batch operations, which we're also going to talk about today. And this is your faster option. And finally, if you have very few objects that you need very urgently, so you need those back in minutes, and very rarely you can use an expedited restore. And we'll give you a tip if you do intend to use an expedited restore. We do recommend that customers purchase provision capacity units, which guarantee that you'll get at least 3 restore requests every 5 minutes. Also wanted to call out for Glacier Deep Archive that if you are using a standard restore there, you should expect your data in about 12 hours, and bulk restore is about 48 hours. So here's where the fun happens. How do we initiate those restores? When you're choosing to restore hundreds or millions of objects, it becomes important to factor in that initiation time. Glacier supports 1,000 transactions per second, and I've done the math. I put it on my slide there, my notes. It's about 86 million requests per day. So the key thing to remember here is that if you have tens of hundreds of millions of requests, you should factor that in for your overall time. So let's say that I want to initiate a restore for Glacier Flexible Retrieval, and I'm expecting to get it anywhere from 3 to 5 hours for my last request. That keyword is last request, okay? So when I make even though I can make my first request right now, if I have 40 million requests, it's gonna still take me 12 hours until that last request is submitted. So that time actually goes out to 15 to 17 hours. And that's where batch operation comes in. If you're getting less than 1,000 TPS, those transactions per second, that means your request is going to take longer to submit. We've seen some customer examples of customers issuing requests at 25 TPS, and it almost increases their time 40x. So you want to be mindful of that. But the good news is with batch operations, you don't have to do any software optimization or multi-threading. It will maximize that for you. So instead of fine-tuning that software, you can use S3 batch operations to automatically maximize your restore requests per second. It also will automatically do automatic retries for you if there's failures, and then it will give you a completion report to let you know if there's any issues with your jobs. How this works is that you will create a manifest that has a list of keys that you want to restore, and then you can either do that through manually, or you can apply filters such as prefix or bucket, and it will create, once you submit that manifest, each manifest will be associated to a single batch job. Now you can run concurrent jobs, but it will split up your TPS, so be mindful for that. And if you have a job that's more urgent than the others, we do recommend you submit that one first, because again, it will split up your TPS there. So next, if you remember our slide a while back, the last thing to consider was the number of days you wanted to retain your temporary copy. So you can you can select to keep your copy from anywhere from as little as 1 day to 1,000,000 years, which sounds amazing. But depending on how long it will take for you to initiate your request, how long that initiation request will take to go through, you also have to consider how long it will take for you to process that restored data. So let's say you thought it would take 30 days to process your data once it was restored, and then you found out it's only going to take about 5 days. I don't think you want to keep your data in S3 standard for an additional 25 days, right? I would assume not. So we do have a solution for you there. You can issue another request, and Glacier will overwrite the original time after you're complete, and so you don't have to have those additional 25 days. But be mindful that you don't have to pay for additional requests, but you will, you do have to pay for the request, but you don't have to pay for any additional charges there. So that was step one, initiating restores. Next, you want to check that your restores are complete. And we have a few ways to do that. S3 provides multiple options for you to check your status. You can do it using the S3 console. You can use the head object command in the CLI or the head object API. And it's also available in the list API. In addition, you can also use an event notification option in AWS such as S3 events notification. Using a notification service will also help if you have a workflow that you want to automate. And we'll go over that next. So with Amazon S3, we'll create those event restore, initiation, and completion notifications, and you can publish these to EventBridge, where you can configure them to fan out to an SNS topic, SQSQ, or it can even trigger a Lambda. And this will allow your workflows to automatically move on to the next step or start processing that data, such as issuing a GET call or copy the object as soon as it's ready. So we've already talked about initiating restores, and we know we need to check for restore completion. Here comes the fun part. We're accessing our restored data. Once an object is restored from Glacier, again, it's going to sit in an S3 temporary S3 standard, and you can access it like any other object in an S3 synchronous tier. So remember, though, that it's a temporary copy. If you want to delete that data from Glacier, you can move it to another bucket, or you can copy it in place. But just remember that if you copy it in place, you might create multiple versions, so you need to check for version sets if you do not want it to remain in Glacier. And that is it. That is how we are going to restore. But I wanted to give you a customer example to walk you through the process of how one of our customers, Deluxe, used batch operations to reduce their storage costs and reduce their restore costs. We worked with them. They are a media company. They are used, their business model is they process media for other content creators, and they were using microservices to initiate requests to restore from Glacier. They realized there was a lot of benefit in streamlining those microservices with batch operations, which allowed them to reduce those costs. Before batch operations, the microservices would issue restore requests as they came in, and this forced them to scale to their peak load. They also would get urgent requests that they would use expedited restores for when they needed to process that information by the end of the day. And so this was, a higher cost because they're using expedited, and they were getting slower restores because they were using standard as they were coming in. So what they did is they changed their restore initiations to a batch operation workflow, and this allowed them to aggregate the requests on their microservice with a CSV manifest. Then every 5 minutes, the service could create a restore batch job using standard restore. And the end result is they were able to save money on restore. So if you look on the chart, with the previous version, they were able to start processing that data after about 3 hours or so. When they switched to batched operations, they were getting data back as soon as 20 minutes that they were able to start processing. So that's a big difference with time. It not only allowed Deluxe to streamline their microservice, but it also was able to increase their restore speeds to minutes rather than hours, as the chart pointed out. And that's because batch operations restores from Glacier Flexible Retrieval, and your restores start to complete in minutes rather than hours. So, our key takeaways from this lesson. You want to preserve your assets, and you can do that at a low cost with Amazon S3 Glacier. You want to choose the correct storage class that's right for you, and you also want to make sure that you're looking for ways to generate value with your code data. And the last point is optimize large-scale restores using batch operations, and you should be good to go. If you go to this QR code, this will give you additional information about S3 Glacier. Thank you for joining us. I'll leave this QR code up, and if you have any questions, we will be over here to the side. And again, thank you for joining us this evening.